Okay, I'm from Intel, the AI Lab. Can Intel have large and full-scale solution for AI from hardware? Okay, hardware specific for AI, optimization of the well-known frameworks and tools and platform to accelerate a lot of AI workload. As you know, of course, the NLP has made a quite large impact in terms of development. And what I want to speak today is about still the adoption of NLP AI in the industry is low. And here are some of the reasons, the challenges. Still, the issue is lack of data and skills. This is from O'Reilly and this is from IBM. Data quality, you need to label a lot of data to train those machine learning AI models. Specifically, if you look on NLP today, not just chatbot, but also text analytics and other use case, usually you have to train a specific model for a specific task. And of course, if you have many languages, again, you need to train, you need label data, you need the linguistic expert, the machine learning expert. Of course, it's very time consuming. And of course, if you're developing in production, the business environment is quite dynamic, so you have to change the model and track the results. If you probably heard about those monsters, if you are familiar with the recent progress in NLP, just a few months ago, starting from Elmo and BERT, things and Ulmfit, those are quite promising technologies that can help us to adopt NLP in the industry. They outperform state-of-the-art in many NLP tasks, and what is nice is that they can transfer knowledge from task to task, even from language to language. So you can train, for example, for a language model task, and then you can use it for name entity recognition or intent extraction. Also, you can train with a small amount of data, and this is quite critical if you want to implement in the industry. You don't have the data like Google, and you need something that you can train with small amount of data. The problem is that those are really monsters. So those has something like 1 billion parameters. And this is quite huge, and it's very hard to run in production. But the promising thing is that there is a lot of optimization that can be done, and this is what we are doing in Intel. Specifically for the Intel AI Lab, what I'm going to speak in the next few slides is about tools for the NLP developers and research community that can learn from small amount of data, label data, and also in most cases you don't need the NLP expert in the loop. And this is part of our open source framework. It's called NLP Architect. NLP Architect is a Python library, license-free. Everything is available in our GitHub repository. This includes a long list of deep learning NLP models from core component and also advanced solution. And also demonstrate Intel optimization. If you're familiar with MKLDNN, this is optimization for deep learning on Intel hardware and other AI platform. So you can use those models as part of your solution. You can integrate it. Again, this is a free license. This is from our portal, very detailed documentation about the models and the solution. Just few models regarding conversational AI, things like, of course, intent extraction, semantic capabilities, syntactic parsing that you can actually deploy in your solution. And also, as I mentioned, we have several solutions that you don't need the NLP expert in the loop. I will speak about two of them. What we also have is a data set we, in the past, developed a personal assistant that is actually a third party in a human-to-human conversation. And it's basically can extract actions and intent that mentioned during interaction between human. And this is, of course, different from a human-to-machine. You can read more in this blog. We also have available a data set that you can test your chatbot for a real human-to-human intent request. And those are a few examples. In many cases, there are no action. It's not like calling Alexa. They are really human-to-human interactions. So just to give you some hints about our application, this is a non-standard NER. This is a NER that you don't need to develop a specific model for a specific entity class. The business analyst can define a specific entity class and then can annotate this class on new data. And you don't have to build a specific model for the entity. Look, another example is our sentiment analysis. We are the first to, just a few weeks ago, we released a sentiment that is based on aspect. So you can see that we have also the opinion and the aspect that related to them. So you can have some kind of statistical report about what are the aspects and what are the sentiment terms. What's nice about that, then this is an example from the UI, analyzing TripAdvisor comments. And what's nice about that is that we understand the domain from the data. You don't have to prepare label data. We analyze the data in unsupervised way, extract sentiment and aspect automatically from your data. And this is, of course, very critical. And this is an example from two domains. One is movie and one is restaurant. And of course, the sentiment terms are quite different. So you can see different terms. And also the aspect are different if you compare laptop domain to a restaurant domain. And this is, it's actually running two lines of code in Python. One is for training and one is for inference. With the training, you just need to provide your data. It's not labeled data. And in inference, you have to provide new data to annotate the data. That's it. Regarding next step, with NLP Architect, we are going to add more solution to the framework, things like event extraction that will not need to build specific model for specific event. And also, it's going to be kind of a developer platform that you can train your model, you can save in any format, and then load those models in production. In addition, we're going to add more feature to optimize NLP models on Intel hardware. So all those large models will be actually efficiently run on the hardware. That's it.